Okay, 4.4. Describe the changes that occur in the orientation of magnetic axis of nuclei before and after the application of a strong magnetic field. So we know hydrogen has a spin because it's got one proton. It's the most abundant in our body with 70%, roughly 70% composition. And if it can have angular momentum, it will have a magnetic field associated with it. We can interfere or play around with our spin. So how we can interfere with that spin is if hydrogen has a magnetic field around it, we know that by the right-hand grip rule in 4.1, then if we apply a strong magnetic field, we can then interact with these hydrogen molecules in your body. And these hydrogen molecules will align themselves either parallel or anti-parallel. And that's mentioned in the third or fourth sentence on the left-hand side of the diagram. So looking at hydrogen in particular, these alignments will either go in the parallel and anti-parallel alignments, and this can be determined by the magnetic field that is applied to this substance or body. So under normal circumstances, there are always more parallel alignments compared to anti-parallel alignments. And once again, the difference is between the magnetic field strength. So if a magnetic field strength of typically 1.5 Teslas, there will be one extra parallel alignment for every 100 million nucleus aligned. So this has two consequences. First is the formation of a net magnetic field. Before the alignment, so this is key to this dot point, the magnetic fields they produce are randomly orientated, therefore they have no magnetic field will be expressed. However, the extra parallel alignments when a strong magnetic field is applied will result in the net magnetic field in the parallel direction. The result of this is known as net magnetization, which is by capital M. So second parallel arrangements can absorb energy, externally applied in the form of pulses of radio waves, and move into anti-parallel alignments. So this can be readmitted, and once these anti-parallel alignments return to original alignments, this is the basis of the MRI, and the computer can gather this data. So for this dot point here, and I've discussed a range of things in the 2 minutes 30, is that before the magnetic field is applied, there is no net magnetic field, so the hydrogen atoms in your body are doing whatever they feel like at that present of time. And when we have a strong magnetic field such as 1.5 Teslas, they will align themselves in a parallel alignment. And we can use this in the basis of taking images for MRI. And when we're looking at the images of MRI, we're actually looking at the alignment of this hydrogen atoms or atoms in your body, in particular hydrogen because it's so abundant. But it is the basis, those alignments are the basis of MRI. I will discuss in 4.5 to 4.8 the purpose of radio waves, which was discussed at the end of this paragraph here. So stay tuned to 4.5, 4.6.